In this tutorial we will discuss and explore the nature of variables. So first of all, what is a variable? Simply put, a variable is a piece of data held within the computer's memory. It can be used to hold the numbers of a shopping bill or the result of a calculation. It can be used to hold a name or an address or anything you wish the computer to remember. As the name suggests, variables can be changed and manipulated throughout any program. It is virtually impossible to write any program without using a variable in some way. The next question is, what type of variables are there? There are three primary types of variables: an integer, a float, or a string. An integer is a whole number. This can be 1, 2, 35, or even 65,543, or anything else you like, as long as it's a whole number. A float is a number that supports decimal points, for example 1.1, 2.2, or 3,403.643, or any other number that is not whole. The final type is a string. A string is basically a collection or a string of characters in a sequence. For example, James, John, or 25A Somewhere Road. I will now take you to the IDE and we can explore how to tell the difference between these different types of variables. Welcome back to the DarkBASIC Professional IDE. Here I will show you how to tell the difference between different variables. So, how do you know what type of variable you're using? Any integer value is a whole number, as I said before, and it's represented by a name. This name could be anything you like, providing it doesn't clash with the DarkBASIC Professional command. In DarkBASIC Professional, it's easy to tell if it does. If the text turns blue, then it's a command already assigned to DarkBASIC Professional, and you cannot use that to hold data. If, however, it's black, then it's usable. Also, please note that variables are case sensitive. To identify an integer to the system, you will have to give it a name without any symbols. For example, my int equals 665782. So my int will now equal that number. As you can see, I haven't put any symbols after the name. I will go through why I mentioned that in a moment. Now, with the hello world command we compiled previously, we pushed a direct piece of string data into the command by putting it in quotes. In this case, I'm just going to type in print, and then I'm going to use the variable name. So if I type in my int, that will now print the content of my int. So now we're going to type in wait key and end. Now let's run the program and see what happens. As you can see, in the same way our hello world box turned up, we've now got a DarkBASIC Professional window with the numbers I typed into the integer. So we'll now close that and go back to the IDE. The second type of variable I mentioned was a float value. That is a number that's not whole, so it could be 1.1, 2.2, as I mentioned before. So we'll just get rid of my int here and my int there, and we'll create my float. Now, the one thing you have to remember with float numbers when declaring them in this way is you have to put the hash sign after it. If you don't put the hash sign, then it will treat it as an integer, and any any decimal points will be ignored. So if we type in 65.665 and then type in my float, again I'm replicating the case exactly, and then we click on compile the program, it will then display 65.665, which is what we typed in. Now if I was to create a second float, my float2 equals 65.665, and we add in a second command, print my float2. As you can see, I've left out the hash, but both pieces of data are basically being assigned the same number. So if we run the program again, you will see that the variable assigned with the hash symbol appears as 65.665, where the float assigned without a hash symbol has appeared as 65. So when declaring floats in this way, it's essential to always include the hash symbol after it. The final type of variable we need to pass to the print statement is a string value. String values are defined with a string symbol, or the $sign. So if I type in my string and put a string after it, then equals. Now, in order to pass any kind of text data to a string, you have to put it in quotes. You can't simply assign a number to it, because your program will crash. I'll just demonstrate that now. If I just type in a random number and then ask it to print my string, the program should crash. As you can see, cannot perform a string cast on that number type. However, if I was to put that data into quotes, regardless of being a number or not, and run the program, it will then display the numbers quite happily. So again, you have to put string data in quotes. And of course, you don't have to just put in numbers. You can type in anything you like. 25A, somewhere road, put in a bunch of different symbols. Oops, I shouldn't put quotes there. Obviously you can't put quotes in there, otherwise you'll be messing it up somewhat. Okay, so we'll just compile that. And as you can see, what we typed in with symbols and all is replicated. Again, we'll take a quick look at what happens if you leave the symbol out. So we remove the $sign from both of them and then compile them, and again it should produce an error. There you go. Because there's no $sign, rather than having string, it's now got integer in the error message, so that's why you need to include the symbols. So that covers the three primary types of variable data and how to assign them to the program. I demonstrated in the last couple of examples how to hard code a variable, so it's got a piece of data that's simply replicated. However, variables are called variables for a reason. They can be changed throughout the program. So I'll now show you how to do that using simple math statements. So we'll start off with an integer value. So my int equals 1. Now we wish to modify my int. So we can change my int equals my int, add 5. So now my int will add whatever data it had previously and add a number 5 to itself. So my int will now equal 6. So we quickly test that. Print my int, wait key, compile that. And there you go. You now have the number 6 displayed. You can also use integers in other integer calculations. So my int 2 equals my int add 5, and you can add another one, my int 3 equals my int add my int 2 times 6 divided by 3, just for a bit of fun. And we will now print my int 3. So we get the number 13. However, mathematics isn't always that neat. You don't always get whole numbers. So we'll change my int to my float, and we'll change divided by 3 to 3.5. Again, we'll update the print statement with my float. As you can see, I've accidentally left out the symbol, so I need to include that. So we now got hash my float hash, run the program, and as you can see, we now have a float number. So now we're going to create a very simple, very quick mathematical program. So we're going to take two inputs from the user, and we're going to use the command input. We're going to pass the string value, type in a number, colon space. We add the space because if you don't, the number you input will be directly after it. It just looks a bit neater. And we'll input my int there, so the user can type in whatever they like. So we've now got input, how many times do you wish to multiply it by, comma, and we'll add a int 2. And now we're going to tell the program to basically multiply whatever the first number the user types in is by whatever the second number is. So print, you can actually do this directly within the print statement, my int times by, which is the asterisk key, my int 2, again, wait key and end, click on run, and we now have the program asking us to type in a number. So I'm going to type in 50, I'm going to times it by 44, and you get the number result at the end. So as you can see, variables can be manipulated and reassigned and adjusted in many ways. And obviously if I typed in a decimal number, because I've set them up as integer numbers, it wouldn't have worked. I just got a whole number. So if I change these to my float and my float 2, change these to my float times by my float 2, run the program again, and if I just type in 5 times 5, you get 25 as you would for an integer number. If I type in 5.5 times 9.5, get 45. And the reason for that, of course, is I didn't add the hash symbol. So we're going to add the hash symbol now. See, it's a very easy mistake to make. We'll run the program again. So 5.5 times 9.5. There we go. We got a proper result now. So as you can see, it's very easy to forget to assign the symbols if you're declaring variables in this way. However, there is another way of declaring them, but we'll get to that in a moment. What we're basically going to do now is demonstrate that you can also perform similar functions to string variables. So we're going to change our program here. We're going to start off by typing in input, open quote, what is your name, question mark. Put a space and a close quote, then comma, name, string. And that will now, the program will now ask what is your name, and you can type it in. So input what is your town name, question mark, again a space. The reason I'm putting a space after it is if I don't, then when we come to typing in the actual program itself, it will appear right next to the question mark. It's not a big issue, it just looks a bit messy, so it's a good way of avoiding that. So town, string, then input, what is your postcode, question mark, space again, and postcode, string. Now we've got 3 different strings here, and what we're going to do is combine them all into one single string. So information string equals name string. Now we're going to use the add symbol. This will basically add another string value to what we're typing in, to the existing variable we just typed in. So we got name, which will be whatever you typed in, and we're going to add a little bit of text formatting so we can actually mix direct strings with strings that you put into other variables by in the same way that you would for print. So name, we want a comma, then a space, and open quotes, then we put add, town, string, add, again we want another quote, comma, space, close quote. The reason we're doing that is when the information string is formatted, it will appear name, comma, town, comma, postcode, full stop by the time we finish. So add postcode, string, add again, open quote, full stop, close quote. So we've now formatted information string to include everything we've typed, or everything the user's typed in. It will format it using commas and full stops, and now we will print the result to the screen. So print information string. You can also do the same thing directly in the print statement, so you could get rid of information completely and just copy the name, town, postcode with its formatting and put it directly into the string statement. Wait key, end. Now we'll compile the program. Okay, so it's now asking what our name is. My name is Daniel. As you can see, because I put the space in the quotes, it's not right next to the question mark, so it looks a little bit neater. My town name is somewhere, and my postcode is a set of random numbers, doesn't matter what I type in, and press return, and there we go. Print has now taken the information we put in, reformatted, and displayed it on the screen, or rather the information string variable has done it. But as I said earlier, you can do the same thing directly in the print command itself. So as there you got Daniel, comma, somewhere, comma, and the postcode followed by a full stop. However, as I mentioned just now, there is also another way of declaring a variable. So I'll just get rid of this program here. and we're going to declare a variable without any kind of symbol. So we're going to start off with integer. Now type in my int as integer, and that will now declare my int as an integer. And if you recall, if you click on variables here, the button, my int has now been displayed under declared variables. So that is now what we've called declared. Now we're going to have my float as float. Now as you can see, I haven't used the hash symbol as I normally do. And we're going to have finally my string as string. Again, it's been declared. So now we need to test these variables. So my int equals a whole number, 99855. My float equals 97, sorry, 0.998. And my string equals, put a bit of data there, my data, then print my int, print my float, print my string, wait key, and end. So I click on run the program, and as you can see, despite not using the symbols, the data is now correct. So we'll close that, and that's how you define a different type of variable without using a symbol. Okay, so I've deleted all that now, and we're going to have a look at other types of whole number declarations we can make. Now there are 1, 2, 3, 4, 5 different types, and I'm going to go through them in order of size. The first thing you will notice is along the bottom here you get some extra data when you declare something. So if I type in my bool as Boolean, it displays a number range. So Boolean range is between 0 and 1. This basically means that that is the whole size of the number you can actually assign. So you cannot actually go above the number 1 when entering it. However, that's the theory. In DarkBASIC Professional there is a minor bug with Boolean declarations. It means you can actually go higher. So if I was to type in my bool equals 5, print my bool, wait key, end, and run the program, you'll actually get a number bigger than the range specified. This is the only error regarding declarations that I've come across. The next one up is something called a byte. A byte has a range between 0 and 255. So my bool, oops, no, we want my byte as byte. Again, it's been declared under declaration, under the declared variables window, and if you put your cursor over it, you'll notice that the byte range along the bottom is 0 to 255. So we're going to try and assign a number bigger than that. So my byte equals 500. Print my byte, wait key, end, and run. As you can see, the biggest number that's able to be displayed is 244. If we type in 255, which is the maximum range, and we run the program, it will appear as 255. So you do get the whole 0 to 255 range. It's worth noting that you can't go into negative numbers. If it says 0 to 255, then it means 0 to 255. It doesn't include 0 to negative 255. So we'll just quickly test that by putting in a negative symbol and run the program. As you can see, the lowest number it could come up with is 1. So that's produced an interesting error. The next one in the size range is going to be a word. So my word equals, sorry, not equals, as word. Again, you've got the range down here. The word range is 0 to 65,535. So we're going to assign 65,535 to it, to my word. Then we're going to print it. And as you can see, you've got the full number range there. Again, if we go above that to 70,000, it produces an error. It can't go up that high, so it's causing a problem. So basically, by the look of it, what it's done is it's actually marked the difference, because it can't count that high. It's basically reset it to 0, then carried on counting. I'll just quickly demonstrate that in a calculator. So if I was typing 65,535 and we add the number that's on screen, 4464, and we get almost the 70,000 we typed in. The reason we haven't got 70,000 exactly is because the computer counts 0 as a number, so it will count 0, 1, 2, 3, 4 rather than 1, 2, 3, 4. So we'll close that down and close the window. The next one in size is a D word, which stands for double word. So my D word as my D word. Again, you got a big range here. You got 0 to a lot of numbers. 4,294,000,000, etc. So I'll just type in that number, 4294967,295. We'll get it to print my D word. There we go. We've got the number we just typed in. Again, if you go over, it should do more or less the same thing. So, so 1, 2, 3. So we get 1, 2, 3, 4, 5, 6, 7, 8, 9. Again, we'll run the program. As you can see, it's counted up from where it was. So, well, not quite, it hasn't in this case, but it's produced a wrong number, so obviously you can't go beyond that range without errors occurring. Now, the biggest number the program can produce is a doubled integer, but before we do that, we'll see how big a standard integer is. So my int as integer. As you can see, that is a huge range. Now, the advantage of this is it will actually go negative as well. So if you assign a negative number, unlike with word and dword and the rest of them we use so far, it will actually support it. So we'll just change print to my int and we'll assign a number to it. My int equals, and there's a number I copied from the documentation I got over there. However, if we put that in negative and then compile the program, as you can see, you got a little minus sign before it. So we'll actually count from negative 21 billion all the way up to positive 21 billion. So it's very useful if you're using coordinates in 3D space, which we will cover at another point. And the final whole number we can assign is my dint, that's double integer. So we'll just change that to double integer. And again, you've got the whole range there, and it's actually so big it goes off the side of the screen. So you've got, but again, as with an integer, it will go in negative and positive directions. So we will now test it. So I'll just update that to dint and double int again. We'll replace this rather long number with a ridiculously long number. I'm not even going to attempt to pronounce that one. And we'll click on run. And the number is now reproduced. However, for some reason it's shown in negative. But that's a little quirk of the program. So what we're basically going to do now is drop the number by 1 to 7 there. We'll run the program again. And it will actually display that number in the positive. So it's worth noting, if you use a full number in a double integer, it will actually go negative. So you need to reduce it by 1. Again, if we put a minus in front of it, it will then go into negative numbers. Again, if you're using 3D space and you need a very big coordinate system, then this is the number to use. We're starting off now by creating a float variable. So my float as float. Now you'll notice down here the float range is a little bit odd. It doesn't just give you the numbers like it did for the whole numbers. I'll explain the E system in a moment, but I just want to go over one thing first. If I assign a number, my float equals 0.0001, and then print my float. Again, we're going to wait key and end. If we run the program, no problem, it's displayed correctly. However, if we add an extra 0, we suddenly got a completely different numbering system. I will explain how the E numbering system works in a moment, but there's something else I want to show you first. So that's basically the biggest number you can store in memory, or rather the smallest fraction you can store without having it converted into the E number system. Basically, the biggest number you can have with this number of decimal points is 10. So if we run the program now, 10.0001, not a problem. That shows correctly. However, if we go to 100, it rounds it off to 100. We lose our decimal places completely. So if we take a 0 from this side, and because we've already added it, we've effectively moved it from the decimal point to the whole number side, and we click on run, we now have 100.001. So the smallest fraction you can have accompanying 100 is 0.00, sorry, the smallest number you can have is 001. So again, if we increase the other side by 10 and run the program, it rounds it off again. Again, we lose our decimal places. And once again, if we delete a 0 off this side, it shows correctly. and of course it will go on in the same state until you hit 10,000. Suddenly it's rounded off, and take away the 0, and suddenly it's not. So the smallest fraction depends on how big the whole number is in front of it. Now if you look at the number of numbers here, or the number of characters rather, you've got 1, 2, 3, 4, 5, 6, 7 units displayed on the screen. Now if we have a look at our float range, you'll notice 7 digits. Now a decimal point is counted as a digit, so you can only actually have 6 numbers plus 1 digit on the screen. Okay, the other thing to note, so if we add another 0 here, we lose our number completely. So we've got 1, 2, 3, 4, 5, 6. We'll add another 0, run the program. There we go, we've gone over to the E conversion system. So it's basically saying number 1, E plus 006. So number 1 plus 1, 2, 3, 4, 5, 6 zeros. So it's basically timesing the number 1 by a million. Or rather placing the 6 zeros after the number 1. Again, if we increase by 2 more numbers, we got 08. And again, we look at our number, we got 1 followed by 8 zeros. So it's literally 1 followed by 8 zeros. Now if we type in 1, 2, 3, 4, 5, 6 and run it, we now have 1, 2, 3, 4, 5, 6 and 13 places. So if we go back, we now have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13 places. So as you can see, it's 13 slots after 1. Again, we'll look at the number in the mathematical system. It is saying 1.2345 So basically it's counting 2, 3, 4, 5 and 6 as extra zeros or extra decimal places forward. And exactly the same thing goes on in the negative direction. So you've got 0.00001. Run the program. And it's now 5 decimal places backwards. So we got 1, 2, 3, 4, 5. Now unlike the one going in the positive direction, there's 1 point something that has 5 zeros behind it if it said 5, this will actually place it at decimal point 5 here. So 1, 2, 3, 4, 5. So if it's 0.1 going backwards, then that's it basically. It's got 1, 2, 3, 4, 5 decimal places backwards. If I type in 1, 2, 3, 4, 5, 6, you'll notice that it's still 5. So that's basically saying 5 starts at decimal point 1 and then carries on from there. So it goes 1, 2, 3, 4, 5 decimal points is where 1 is located, and then it's 2, 3, 4, 5, 6. And that's how the system works. Now again, if we have a look at float, we basically got an option of 38 decimal places. So I can go back 38 decimal points, and it will then show 1.23456 minus 0.38. Okay, I've quickly typed in 38 zeros there, so we'll now run the program. Or rather, 1 takes the place of the 38th decimal point. So as you see, so it's 38 decimal points forward of 1, 2, 3, 4, 5, 6. Now if I was to type in some extra numbers here, 7, 8, 9, and then run it, it says exactly the same thing, but you'll notice 6 has been rounded off up to 7. So I say this is basically a way of rounding it off. I say when the E system kicks in, as I say, you cannot go in both directions at the same time. You can only go in positive or negative directions, as indicated here. You can either have plus 38 zeros or minus 38 zeros. You can't have plus and minus, unfortunately. So that's how the float system works. It's very confusing to a lot of people, but now you understand how it's rounded off and averaged. You should have no problems using it. The final way of setting up a variable in a program is to set it up as a global. Then you type in the variable name, myVar, and you can still declare it as an integer. And this will basically allow this variable to be assigned to all parts of the program. The reason we do this is if you've got multiple source code files and different functions in different places, this ensures that the entire program will know what myVar is, and for this reason it has to be declared at the beginning of every program. The opposite to this would be local. This is only used within a function environment. So as soon as a function starts, that variable exists. Type in local myVar, it will run through its program or through the instructions using that variable. Then as soon as end function is hit, it's disposed of, and nothing else in the program can actually access it. So it's a very good way of storing temporary data in memory while you're using a function. I'll cover functions later on in the tutorial, so you'll understand them a bit more then. So that about wraps it up for this variable tutorial, and I'll take you on to the next one.